Good morning, 6th grade. Welcome to lesson 43. We're going to switch between fractions, decimals, and percents today. It's going to be awesome. Let's see how you did on your power up letter I. We're finding proportions, missing numbers in it. I'll rattle through them. You could have solved it through cross multiplication, or you could have solved it by either reducing or finding the equivalent fractions. I'll rattle through the 15 answers. I'll probably get one wrong. Circle the one I get wrong. I like to say circle the one you and I disagree on. So anytime I say an answer that's not the same as you just circle that one. And sometimes you might have got it wrong, or sometimes I might have got it wrong. Okay, letter A would be 9. Letter B would be 16. Letter C would be 3. Letter D would be 4. Letter E would be 6. Next row, F would be 20. G would be 20. H would be 50. J would be 32, K would be 2, last row, M would be 48, W would be 15, P 15, Q 45, R 40. Kind of like how your book starts alphabetically and then all of a sudden just, no, they decide to stop going alphabetically, whatever. Mental math would run like this, guys. You multiply on the top, you got $2.88. Divided is move that decimal left 2 times. 0.035, said correctly, 35 thousandths. I divided both numbers by 3, gives me a 7. 7 squared is 49, square root of 100 is 10, 49 minus 10 is 39. Estimate 10 times 6 is 60. Fraction divided by 5 is 60, multiply by 1 is still 60. Put a dollar sign on it. Dollar sign was the one on top of it. F is just 60. Find the range of these sets of numbers. Well, the biggest number is 99. The smallest number is 23. Range says subtract biggest from smallest and get an answer of 76. Add, subtract, multiply, and divide those two fractions. To add and subtract them, any common denominators. The common denominators are 12, so I have 8 twelfths plus 3 twelfths is 11 twelfths. Subtracting 8 twelfths minus 3 twelfths is 5 twelfths. Multiplying, I canceled. The 2 goes into 2 once, and the 2 goes into 4 twice, so I have 1 on the top and 6 on the bottom, 1, 6. Stay, changed, flip. 2/3 stays the same. Change the multiplication. 1/4 flip. So I multiply 2 times 4, get 8. Divided by 3, get 2 2/3. Okay. Challenge problem says this. Maeve sees the 3 faces of each of the 3 number cubes for a total of 9 faces. So you have 9 question marks there. If the sum of the dots on the 3 faces of each number cube is different, and maybe sees 40 dots altogether, then which faces must be visible on each of the number cubes? Okay, guys, I'll show you how I took on this problem to be able to get it. Remember our keys with number cubes. 1 is always opposite of 6, 2 is always opposite of 5, and 3 is always opposite of 4. So if I'm seeing one of those numbers, I can't be seeing the other one. The next thing I said is they see a total of 40 dots, and there's 9 faces. So I divided that in there, guys, and I got 9 goes into 40 4 times. That's 36. Subtract, give me another 4. It's going to be from yesterday's lesson, 4.4 repeating. So, guys, the only reason I did this is it tells me I want big numbers. I need to average 4.5 each one. So the first number cube I'm going to do is this one. I see the 6, I see the 5, I see the 4. And I'm just going to do 6 plus 5 plus 4 and get an answer of 15. Now I'm going to go over here just to help me do the math. I'm going to do 40 minus 15 and get a 25. Okay, now the next one I'm going to do is I know these numbers have to be different, so I can't just do 6, 5, 4 again. So I'm going to do 6, 5, 3 this time. So I got a 6, a 5, and a 3. I'm going to add those together. It's 1 less, so that's a 14. And that gives me an 11. Now I'm going to see, can I add up and get to 11 with the numbers that I have? So 3 plus 2 is 5, plus 6 is 11. So 3 plus 2 plus 6 gives me an 11. This gave me a 14. 3 plus 2 plus 6. You see how I always pick them on the opposite side? Just like that, I have my problem solved. So guys, there's some guess and check to it, but there's also math logic to it. The math logic was I need to pick the biggest ones I can, and then the last one just make sure I add up to what's there. But you also have to make sure you didn't say, how did I get to 11? I did 3 plus 4 plus something, or 1 plus 6 plus 4, because I can't have a 1 and a 6, guys, because they're on the same opposite sides and you wouldn't be able to see them. So your answer is, one dice has 6, 5, 4, one has 6, 5, 3, and one has 3, 2, 6. Probably should have wrote that numerical order, 2, 3, 6, 3, 5, 6, 4, 5, 6, but you have the 3 that are there. Great problem, guys. That makes you think pretty good and yet have some logic to it. All right. You need your yellow folder out there today to be able to work these problems, to write your helpful hints down. Let's get rolling on it. They're going to give you an introduction to each one of the skills we're going to work on. We're going to switch decimals to fractions, we're going to switch fractions to decimals, and we're going to switch percents to decimals. Eventually, we'll be able to go the opposite ways. We'll be able to do percents not only to decimals, but percents to fractions as well, and fractions to percents and things like that. It says to write a decimal number as a fraction, we write the digits after the decimal point as the numerator. So that's what I wrote in your notes, guys. What do I do there? To be able to switch those things decimal place, it says decimal is my numerator. Place value is my denominator. For the denominator of the fraction, we write the place value of the last digit, then we reduce. So number 1 says, please write 0.125 as a fraction. Now, guys, there's a couple ways to do this. Number 1 is just count how many fractions you have, and that's how many zeros you get on the bottom. So the first thing I can do is, my decimal is my numerator, so that's 125. How many zeros, how many numbers are there? 1, 2, 3, so it's 1, 2, 3, and I get it. It is one reason, though, your teacher's been saying, don't say 0.125, say it correctly, 125 thousandths. As soon as I say it correctly, guys, I'm instantly done. I have 125 thousandths. Now, the challenge with this one, guys, is you need to reduce. Okay, so I reduce, I divide by 25 here. 25 goes into 125 5 times, 25 goes into 140 times. I notice that the ends in 5 and 0, so I divide by 5 again. When I divide by 5, 5 divided by 5 is 1, and that's 8. This reduces to 1/8. Be a great one for you to memorize. Okay, example number 2 on the back side says, Martha rode her bike 11.45 or 11 and 45/100ths of a mile to the lake. Write it as a mixed number. So the whole number stays the same, guys. The fraction becomes, the decimal becomes the numerator, the place value becomes the denominator, and I just have to reduce that. Divide by 5 for this one is 11. Divide by 5 is 9. Divide by 5 is 20. 11 and 9/20ths of a mile. Okay, so how do I switch decimal to fraction? Decimal is my numerator, place value is my denominator, and reduce it down. How do I convert fractions to decimals? It says to change a fraction to a decimal number, we perform the division indicated by the fraction. The fraction 1/4 is simply 1 divided by 4. So 1's inside the box, 4 is outside the box. We like to say top in, bottom out as we work those things. And so that's what I wrote there, divide, and then there's a blank after it. I usually just write the letters TIBO, top number in the box, top in, bottom out. That's what I want you to put on the line. Okay? Good chance for extra credit number 2 on the front side. You write the 4 letters, TIBO, so that I know you know how to do TIBO, top in, bottom out. It may appear that we cannot perform this division. However, if we fix a place value with a decimal point and write some zeros in the decimal place to the right of the decimal point, we can perform it. So when I write 4 divided by 1, I don't know what to do. As soon as I write 4 into 100, I can see it goes in there 0.25 times. Some fractions convert to repeating decimals, which you learned yesterday. We convert 1/3 to a decimal by dividing. It's going to go in there for forever with the 3, so it's 0.3 repeating. Every fraction of whole numbers converts either to a terminating decimal, like 0.25, or a repeating decimal, like 0.3 repeating. 3 says find the probability of the spinner stopping on 5 and write it as a decimal number. So guys, I see there's 5 of those. There's 1 5, so I wrote 1/5. Now what they're saying is I didn't ask you for a fraction. I asked you as a decimal. And so can we get it there as a decimal? Sure. Top number in, bottom number out. 5 goes into 1 0 times. Add a decimal, add a 0. 5 goes into 10 2 times. Problem solved. It's 0.2. Number 4, it says write each of these as a decimal number. Okay, so we're cruising through here, guys. This one's nice and easy for me. 23/100ths, 23/100ths. They're not going to give you too many that are like that. Next one they give you is 7/4. It's just a division problem, guys. Top number in, bottom number out. 4 goes into 7 once. Add a decimal, add a 0. That's 4, subtract 3, bring down that 0. 4 into 30, 7, 28, subtract 2, add a 0, bring it down. 4 into 25, it's 1.75. Next one, you got two choices when you have a mixed number, guys. One is just mess with the fraction and put the whole number on top of it. 2, switch it to improper. So if you forget the whole numbers, guys, then switch it to improper. If you're good at remembering the whole numbers, I'm just going to mess with the fraction. Top number in, bottom number out. 5 goes into 4 0 times. Add a decimal, add a 0, add a decimal. 5 goes into 48 times. Now my answer is not 0.8. My answer is 3.8 because I need to remember my whole number. Okay, so if you like to erase and put the whole number back into it, great. You do the division here, guys, and when you get to your answer key, you just put the 3 in front of it, and away you go. The last one they give you is 2/3. This is one of those repeating ones. Hopefully you have it memorized. Top in, bottom out. 3 goes into 2, 0, decimal. 3 goes into 20. 6 times, that's an 18. It gives me a 2. Bring down another 0, goes in there 6 times, that's an 18. It gives me a 2. I just had 1, 2, my third 2. I know it's repeating, written correctly as 0.6 repeating. Don't just put a bar over this, guys, and call it 0.66 repeating. What number's repeating? Only the 6. This is not math written correctly. This is math written correctly, and we have to make sure we write math correctly. Example 5 says, can you compare this? Well, guys, here's how I do this problem. I have 3 tenths, I just add zeros. I have 30 hundredths. I'm going to make this one out of 100. I need one more decimal place. What's one more decimal place? It's a 3. You had that one yesterday, you had it again today. How they give it to you is they say, hey, compare those. They didn't tell you to switch them to decimals. They didn't tell you to switch them to fractions. You could have made this one 0.3, like 3 tenths. Anyway, you look at it, 3 tenths is less than 3 tenths repeating, 0.3 repeating. Last but not least, in page 312 at the bottom, it says, recall that percent means per 100 or hundredth. So 75% means 75 hundredths, which can be written as a fraction or as a decimal. So percent over 100. Likewise, 5% means 5 hundredths, 5 over 100 or 0.05. We see that a percent may be written as a decimal using the same digits, but with the decimal point shifted 2 places to the left. And so the easiest way to switch percents to decimal, guys, is what we say, left twice, left twice, left twice. Fill in your blank. Left twice, left twice. Let's do it as we work these last problems over here. I'm at 25 as a whole number. 1, 2 equals left twice, 0.25. Left twice is 1.25. Left twice. You're like, Mr. Bauer, it's already a decimal. No, it's not. There's a percent sign there. Anytime they say percent to decimal, even if there's a decimal there, guys, left twice. Uh-oh, I'm out of places. What do I have to do? I add a 0. So that equals 0.025. 50%, 1, 2. What did you have to do with this one? This one you had to learn how to chop off that extra 0. So 5, 0, gone. So I chop off a 0. This one, I have to switch a fraction to a decimal before I go left twice. Now, hopefully you have it memorized, guys. 1/2 is 0.5. So this is 7.5%. Now, left twice. We're combining this one step harder. So I have that equals 0.075. We use this with taxes all the time. The tax rate is 7.5%. Learn to write it as 7.5%. And then switch it for math. Last but not least, left twice is 1, 2. We chop off 2 zeros. It's the whole number 3. So guys, this one in my mind out of the 3 we're doing today is the easiest. All I have to do is left twice, but I need to know 1, how to switch fractions to decimals, 2, how to add a 0 if I need to add a 0, or 2, how to chop off zeros if I need to chop off zeros. Awesome. Let's get set for working some problems. 6, here we go with our problem set from lesson 43. Number 2 says Eric ran 8 laps in 11 minutes 44 seconds. How many seconds did it take him? So I know there's 60 seconds in a minute. So I'm taking 60 times 11. Totally did that wrong. and getting 660. I have to add the 44 to that. Gives me a 4, gives me a 10, gives me 704. So for A, I have 704 seconds. B says, what's the average? So now I take my answer of 704 and I divide it by the 8 laps. And that goes in there 8 times. 64, subtract is another 64. So he's averaging 88 seconds per lap. That's on a normal track, and he's in high school. That's not bad. It's not that good. Number 6. We're trying to work a stem and leaf plot. Okay, so they give you all those numbers, guys, and it says find the median. Well, I have to count how many numbers there are. So you're counting just the leaves, guys. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 times. So I take 15, I divide it by 2 is 7.5. So I count from the top 7 numbers. So 2, 3, 4, 8, 0, 3, 4. It's the next number, which is the 5, and I needed to put it together with the 13, and that thing says, so that would be 13.5 seconds. Now I take this 7, guys, and I divide my 7 by 2, which is 3. So now I start at the top, and I count down 3. So 2, 3, 4. It's the next one, which is that 8, which would makes it 12.8. Then you start at the bottom, guys, and you count backwards 3. So 5, 2, 8. The next number is that 7, so it would be 14.7. So remember, take my overall total, cut it in half. That gives me my median. Then take my median answer of 7 and cut that in half from the top and then from the bottom gives you your other 2 answers. Okay, these are each in seconds, guys, so don't forget your labels. Number 7 now says, can you make a stem and whisker plot from this information? You got it. So I'm just going to do it right on the bottom here, guys, and I'm going to go like this. I go from 11 to 15.5. So I'll make this one 16, 15, 14, 13, 12, 11. That was not very good spacing at all, so I'm going to try to fix it a little bit and space it out a little bit better. It's still average because my 11's a little close. Okay, guys, now I'm just using all the numbers. The smallest number is 11.2. The lower quartile is 12.8. The median is 13.5. The upper quartile is 14.7, and the biggest number is 15.5. So I got my 5 dots. I just make lines out of the middle 3, connect those lines, and then draw a line to that last dot. And you have your box and whisker plot. It's not beautiful because I didn't space it the right, guys, but now you have your box and whisker plot, okay? So keep practicing the math behind that, following along what we're doing to get those things. You're going to have to do that on your own on a test. Number 8. A square and a regular hexagon share a common side as shown. The perimeter of the hexagon was 120. What's the perimeter of the square? So they got a square inside a hexagon, and they said this thing is 120. So I'm going to take 120, and I'm going to divide it by 6 because there's 6 sides on a hexagon. That gives me 20. That tells you this bottom guy is 20, and I know there's 4 sides on a square, so 20 times 40 is 80. Label would be millimeters. They continue to work those with us. Now, number 9, write these numbers as reduced fractions or as mixed numbers. Letter A, I have 375 over 1,000. Okay, I know it can go by 25, guys, so I'm going to start by dividing by 25 over 25. 25 goes into 37 once, goes into 125 5 times. 25 goes into 100 4 times, goes into 0 0 times, so it's 40. I see that I can divide again by 5. That gives me 3/8. You might have that recognized as 0.375 is 3/8 if you don't start to get it memorized. B, I have 5 and 55 over 100. Dividing by 5 over 5 equals 5 and 11/20. And C, I have 250%. They want it as a fraction, guys. Remember, percent means over 100. So I divide by the 10 and cross off those zeros. Divide by 5 gives me 5 over 2. 2 divided by 5 is 2. I have 1 left over. It's 2 1/2. Good practice there. Number 10, write each of these numbers as a decimal. Okay? Top in, bottom out. 5 goes into 2 0 times. 5 goes into 20 4 times. Now I go back and I add my whole number to that, guys, so I have 2.4. B, top in, bottom out, 1. Add a decimal point. 8 goes in there 0 times. Decimal straight up. 8 into 10 once. 8. Subtract 2. Add a 0. Bring it down. 8 into 20. 2. 16. Subtract 4. Bring it down. Goes in there 5 times. I have 0.125. And C, 250%. Remember, left twice. 1, 2 equals 2.5. I do not need that other 0 here, guys. I cross it out when I write it. 2 5/10. Number 14. It says draw AB 1 centimeter long. Boom. Draw AC 3/4 perpendicular to AB. This is AC. What did just happen there? I just bumped a button. Sorry, hang on. Coming back around. AC. Okay, then complete drawing this one. Awesome. Boom. And I drew that one. All right. Then it says measure this one. This one was 1. This one is 3/4. This one is, well, Pythagoras taught me a squared plus b squared equals c squared, guys. So you have a 3, a 4 over 4, and a 5 over 4 right triangle. So that equals 1 1/4. Now the easiest way for you right now would be to pull out a ruler, but 3 squared is 9. 4 squared is 16. That equals 25. 5 squared equals 25. That's a squared plus b squared equals c squared. Shortest side times the next side equals the longest side squared, guys. Awesome. There's your answer for number 14. Turning your answer key over. Number 16, make a factor tree to show the prime factorization of 900. They even told us this first step, start with 30 and 30. That's 5 and 6. That's 5 and 6. That's 2 and 3. That's 2 and 3. A is done. B says write the prime factorization using exponents. Start with the smallest. I got 2 of those. So I got 2 squared. I got 2 of those times 3 squared. I got 2 of those times 5 squared. C says write the prime factorization of 900. Well, guys, they gave you the prime factors. They gave you the square root. It's 30 times 30. So what's just 30? 30 is this thing right here. So the prime factorization of 30 is 2 times 3 times 5. Remember, the other way to do that is divide your exponents in half. So you'd have canceled, canceled, and canceled down to ones. Number 18, write 8% as a decimal. Percent means left twice. 1, 2, decimal point. Add a 0, and then add a 0 in front of it. B, find 8% of $8.90 and round to your nearest cent. So they're practicing this tax with you guys. 8 times 0 is 0. 8 times 9 is 72. Write the 7. 8 times 8 is 64 plus 1 is 71. 1, 2, 3, 4. 1, 2, 3, 4. Decimal point. Dollar always has 2. Look to that one. So I have 0.71. It's 71 cents of tax on an $8.90 item. Number 19, refer to the figure at the right. Find the perimeter of the triangle, find the area. Okay, it's a right triangle, guys, so to find the perimeter, I just add them all up. 1.0, 0.6, 0.8. They're practicing adding with decimals. That's 14, carry the 1. That's 2 decimal points straight down. I have 2.4 meters. To find the area, I take the right triangle measurements. So this one and this one, which is this one and this one. Now, guys, you can chop one of those in half. I'm going to chop that one in half to 4. 6 times 4 is 24. 1 decimal place, 2 decimal places, 1, 2 decimal points. So it's not the same answer, guys. One is 2 4/10, the other one is 24 hundredths. I wrote down centimeters. Sorry, it's just meters. I'll get rid of that stuff. So this is area would be meters squared. A, B. Number 21, we're continuing to show 2 ways to evaluate this. I have A equals 2, parenthesis, B is 3 plus 4. Way 1, add, then multiply. Way 2, multiply, well, we should say distribute, and then add. Second round practicing that one, guys. 23, I am missing a number in addition. Anytime I'm missing an addition, I subtract. So I have 1 9/10 minus 42 hundredths. Add a 0. Can't do it. Borrow 8, 10. 8, 4, decimal straight down, 1. 148. Turn the page in your book, number 25. We're subtracting 3 3/10 minus 1 11/15. Common denominators would be 30. Times by 3/3 would be 3 9/30. This would be times 2/2 would be 22/30. Can't do that. Borrow becomes a 2. I'm adding a 30 to the 9 is 39. Subtract is 17/30. 2 minus 1 is 1. 1 17/30. 29, find the measures. They gave me 50. They also gave me 110, guys. So the first thing I do is I start up here to get A. 110 is on a straight line, so I subtract it from 180. Measurement of A is 70. Now I'm inside this triangle. 70 plus 50 is 120. Triangles add up to 180. So I got 180 minus 120 is 60. And then straight line is 120. So B equals 60, C equals 120. Don't forget your degree symbols. And 30. Refer to the figure at the right for ABC. Write the measure of a central angle AOB. AOB forms a straight line, guys. So that's 180 degrees. What appears to be the measure of A to C to B? Well, guys, appears to be a right angle, so I'm going to say that's 90 degrees. Now, notice how they use the word appears. They didn't put that box in there, guys, so I'm only going with looks. Chord AC is congruent to BC. What appears to be the measure of this triangle? So, guys, this length is the same as this length. Therefore, this angle is the same as this angle. So, triangles add up to 180. I know I have a 90, so I subtract 90 from it, and this angle plus this angle equals 90, and they're the same. So I take 90, I divide by 2, and I get 45 degrees. So they're teaching you how you have an isosceles right triangle, which is 40